Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss IIT JEE Physics Numerical. Today's lesson will be for motion in 2 or 3 dimension part 2. Part 1 already we have completed. So the prerequisite of part 2 is please watch the video for part 1. We are doing the numerical step by step according to their complexity. So it is suggested please go through the part 1. Before we begin, please subscribe, like and share our channel. Please click on the subscribe button to support us and please click on the bell icon to get automatic notification whenever a new video is uploaded by us so that you should not miss any of these lessons. So today we'll do the fourth numerical. The position of a cat running in a park is given by r is equal to 0.280 meter per second, t is equal to 0.036 meter per second square, bracket close, t square, bracket long bracket closed, I plus 0.0190 meter per second q, tq, So from this equation, what is this equation? This equation is simple where position vector is given and this part is x component of the position vector and this part is y component of the position vector. Now, what are Vxt and Vyt, the x and y components of the velocity of the cat as function of time? So we have to find the velocity component of x and velocity component of y, or y component of the velocity for the cat as a for the cat. First step is that. Second step is at 5 t is equal to 5 seconds how far the cat is from the initial position. Now you have to find the position vector when t is equal to 5. Second, last part, that is C part, is you have to at 5 seconds what is the magnitude and direction of the cat's velocity. So you have to find the velocity magnitude and direction of the velocity at t is equal to 5. So at t is equal to 5 you have to find the initial position of the cat. So first thing is we have to write the x component and y component from the equation. So x component will be bracket, small bracket. So big bracket is not required here. So you can write just the small bracket 0.280 meter per second t plus 0.036 meter per second square. This is t square. This is the x component. So you can write x here. And so if this is x, then dx by dt, if we differentiate it, we'll get 0.280 meter per second. So dt by dt is equal to, so write it here, no problem in writing, just dt by dt plus 0.036 meter per second square. So dt square upon dt, this we can write as Vx, dx by dt can be written as Vx, and upon solving we get 0.280 meter per second plus 0.036 meter per second square multiplied by 2t 2 minus 1 2t 2 minus 1. These are simple differentiation formulas. So 280 meter per second, and this can be written as 0.072 meter per second square. We have multiplied by 2, and what is left here? T. So Vx is equal to this much. And similarly, if we want to find, so what formula we have used? We have used dtn dt is equal to t is equal to n multiplied by tn minus 1. So this is the formula which we have used, differentiation formula which we have used here. So now the second step is we'll write the y component. Y component. So y will be equal to, from the equation, y will be equal to 0.019 meter per second cube to the power t to the power cube. So this is the y component. So similarly we can write dy by dt will be equal to 0.190 meter per second cube multiplied by directly if we do the differentiation 3 minus 1, and again dy by dt can be written as Vy, which is equal to multiply 0.0190 by 3, we get 0.0570 meter per second cube and t square. So this is the Vy component for the function of t. And we have missed to write here Vx component for the function of t again. So is equal to this much. So we have found the Vx and Vy component for the function of t. Now we can write the so part B of the question is we need to find the position of the cat after t is equal to 5 seconds. So t is equal to 5 seconds. So it just will put the value in this equation in the x component here. So in x component just will put the value of 5. So it can be written as so it can be written as we'll first write the x component, that is again we have to write 0.280 meter per second t plus 0.360 meter per second square t square, and putting the value of, so this is x which is equal to 0.280 meter per second multiplied by 5 plus 360 meter per second square multiplied by 5 square, that is 25. Upon multiplying and resolving, I am doing it in calculator. So we get 2.30 meter, and again we have to find the value of y. For that we have to write the y component. So y component is equal to, we can write it as 0.0190 meter per second cube tq. This is the y component. So putting the value of 5 here instead of t, so we'll get 190 meter per second cube multiplied by 125. If we put 5 q will be 125. Upon solving we get the value of, I am finding it out in calculator, that is 2.375 meter. So now x and y components are known to us. Now what we'll do, we'll find the we'll find a. A is the magnitude. So or write it r, it will be better because it is given as r. R is equal to x square plus y square. Put the value of x square and y square, that is 2.30 square plus 2.375 square, and under root of it. Upon solving we'll get 3.31 meter. This is the answer. For the third case, third part of this sum, for the to solve the third part, we'll put the value of v of t is equal to 5 in this equation, vx in vx equation, and t is equal to 5 in vy equation. So let us put it. So Vx is equal to Vx for the function of t is equal to 0.280 meter per second plus 0.072 meter per second square t. So instead of t, what you do? Instead of t, you put 5. Why? Okay. In the next step we'll do. So Vx t is equal to 5 will put as, so this value will become as at 0.280 meter per second plus 0.072 meter per second square multiplied by 5. So which will become, upon solving, just solve it, and this value will be 64 point also 0.64 meter per second. Similarly Vy 5, just put the value of t and you'll get 1.425 meter per second, and then find out v is equal to vx square vy square, and upon solving put the value of vx and vy, you will get v is equal to 1.56 meter per second. This is the magnitude. To find out the direction, it is easy. Just here I am writing tan theta is equal to Vy by Vx. Put the values here, then you'll get 1.425 upon the next value is uh, 0.64. So 64 0.64. So upon solving we get theta is equal to, see the log for the value of theta, so it is 65.08, and this is the answer of the direction. So from where we got the value of Vy and Vx, Vy and Vx values are we got from here. This is one of the value, that is Vx, and this is the value of Vy, and upon solving we got 65.8 degree the direction, and this is the solution here. Let us move to the next question. So the next question, question number 5 is a jet plane is flying at a constant altitude. At time t1 is equal to 0, it has component of velocity vx is equal to 90 meter per second. So the values, just you underline it. Vx value is this much, Vy's value is 110 meter per second. At time t2 is equal to 30 seconds, the components of Vx is equal to minus 170 meter per second and Vy is equal to 40 meter per second. Part A of the question is sketch the velocity vector at t1 and t2. How do these two vectors differ? For this time interval, calculate first the component of average acceleration that you need to find and the magnitude and direction of the average acceleration. Okay, fine. So let us see the solution. Now, part A, the velocity vector at t1 is equal to 0 and t2 is equal to 30. We need to draw the graph. So let us draw the graph first. This is x-axis, this is y-axis. So at, say, this is the Vx and this is till here it is Vy, sorry, this is Vy and this is Vx, and the line will go in this way, straight line, which can be written as, drawn as this. So this is the velocity vector v. In the second case, this is x, this is y-axis, this is x dash axis, this is, so the component of velocity vector vy will be this much, the component of velocity vector vx will be this much, and this will be given as in this way. So draw a parallel line here. So this is Vx and this is Vy. So this is the graph at t is equal to 0 and at t is equal to at t1 is equal to 0 and at t1 is equal to t2 is equal to 30.0 seconds. Now we need to find the acceleration. So acceleration, B part, we are in B part, so we need to find the acceleration. So acceleration average is for x component is equal to, acceleration is rate of change of velocity. So the change of velocity is this and divide by time, it is the rate. So v2 x component minus v1 x component upon t2 by minus t1. So put the value of v2 x component of v2, that is 170 meter per second, minus x component of v1 is 90 meter per second upon 3.0 3.0. So upon solving, we got minus 8.67 meter per second square. Now, similarly, we have to find the average acceleration of y component, that is delta Vy upon delta t, which is equal to V2y minus V1y upon T2 minus T1, which is equal to 40 meter per second minus 110 meter per second upon 30.0 second. Upon solving, we get 2.33 meter per second square. Now we'll go to the next part where we need to find the magnitude and direction. So magnitude of average acceleration is AV is equal to under root A AV x whole square A AV y whole square, and put the value of AVX and AVY, we can get minus 8.67 whole square plus minus 2.33 whole square is equal to, upon solving, we'll get 0.0269. No, oh, this is the angle. Okay, so upon solving, we'll get 8.8 8.98 8.98. So this part just you can do it by calculator to save your time. So these are normal simple mathematical calculations. So tan alpha is equal to, we can write AV average acceleration of y component upon average acceleration of x component, which is equal to minus 2.33 meter per second square upon minus 8.67 meter per second square, which is equal to 0.269. So now here we have to draw the graph. To find out the angle, we have to draw the graph. So x, this is y-axis. Now average acceleration, which is in minus, that is minus 0.233, will be somewhere in this direction, and average acceleration of y will be somewhere in this direction. So just so the average acceleration for these two y components and x component will be somewhere in this direction. So draw the parallelogram here. So let it be this. Now this is average of AX. This is average of AY. AY. Then the angle will be, alpha will be in the this direction. So from here we got 10 alpha is equal to 0.269. So alpha is equal to 15 degree here, the angle, but 15 degree is only this much, this angle. So to find out the total angle is alpha is equal to, we have to write 15 degree plus 180 degree. From here this is 180 till here it is 15, so total is 195 degree. This is the angle. And let us move to the next sum. Sum number 6. A cat running in an open field has component of velocity Vx is equal to 2.6 meter per second. So here some corrections, per second, and Vy is equal to minus 1.8 meter per second at t is equal to 10 second. For the time interval for t1 is equal to 10 second, to t2 is equal to 20 second. The average acceleration of the cat has magnitude 0.45 meter per second square and direction 31.0 meter 31.0 degree measured from plus positive x-axis towards the positive y-axis at t is equal to 20 seconds. What are the x and y component of the cat's velocity? What are the magnitude and direction of the cat's velocity? B is what are the magnitude and direction of the cat's velocity. C, sketch the velocity vector t1, t2. How do these two vector differ? So part A of the question is what are the x and y components of cat's velocity. So it is similar to the previous sum. We have also done the same question here. So we'll we can just go it little fast in this case. So ax will be delta v x upon delta t, and Vx is equal to 2.6 meter per second plus 0.39 meter per second square multiplied by 10 seconds, which is equal to 6.5 meter per second. And acceleration will be equal to delta Vy upon delta t, and Vy will be equal to 1.8 meter per second plus 0.23 meter per second square multiply by 10 seconds, which is equal to 0.52 meter per second. Now part B will be equal to V under root 6.5 meter per second whole square plus 0.52 meter per second whole square is equal to 6.52 meter per second, and angle will be equal to, say, tan theta will be equal to Vy upon Vx, which is equal to 0.52 upon 6.5, sorry, 6.5, which is, so theta will be equal to, upon solving this, 4.6 degree. 4.6 degree. Now for the third case, so we have found the x component of acceleration, y component of acceleration, then we have found the magnitude of velocity, and the angle, the direction of the velocity. Now the next step is we have to find the graph. We have to draw the graph. So let us draw the graph. So this is x-axis, this is y-axis, and v1 will be equal to somewhere this direction. This is v1, and v2 will be equal to just above the horizontal expression, this one. So this is v2. So v1 is at angle 35 below x-axis, and its magnitude, so this is approximately 35 degree, and its velocity is, its magnitude is 3.2 meter per second, and v2 will be this, that is 4.6. v2's value will be, from here you just find out the v2's value, so it will be something 4.6 or near about 4.6 something. So this is v2, and we can see that v2 is greater than v1. That's the comparison. And this is the end of today's session. Please subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our videos and supporting us.